All right, here's your epic video about the Excel LAMBDA function. Now, I originally posted this for the MECS class back in 2022. But since 2022, a lot has happened to LAMBDA. We have amazing new LAMBDA helper functions and even more amazing Eta-LAMBDAs. So this is a redo of this awesome Excel LAMBDA video. Welcome to Microsoft 365 Excel, the complete story. And this is video number 10. We finally get to talk about the amazing Excel LAMBDA function. That's a function that allows you to define your own function and reuse it in the worksheet without using VBA. Also, you'll be able to create LAMBDA helper function formulas directly in the worksheet cells. And when we talk about LAMBDA, we also got to talk about let, defined names, and single cell reports. These together are the new frontier of Excel. Now, here are the topics for this video. And if we're going to talk about LAMBDA, we got to talk about defined names. Because if we want to save and reuse a LAMBDA function, we do that inside of defined names. We can also do it inside of the advanced formula environment, which is connected to defined names. So we're going to start with defined names. And actually, I'm going to show you a bunch of tricks about defined names. And there's some good ones. Then we'll talk about LAMBDA, all of the LAMBDA helper functions, the let functions for when we have repeating elements and formulas, and then a bunch of advanced topics about reporting with dynamic spilled array formulas. Now, I got to give a shout out to our YouTube teammates Excel LAMBDA and Gert, who helped me learn most of what I know about LAMBDA. Now, if you've been following along with this MECS class, you know there's a lot of content in the videos. Well, our teammates, Don and Bill, created an amazing download that allows you to track your progress through the MECS class. This link is here in this workbook and below the video. Now, you can download this, but you're not going to believe it. Here's video number 1 and all of the time hyperlink table of contents. And here's a link for you to go and jump to that part of the video. And look at that. They did this for all of the videos. Now, I'm filming 10 right now. They'll add 10 to this soon enough. And you can explore this, but there's some amazing things like being able to search for a particular topic. Man, we have an awesome Excel team. Thanks, Don and Bill. All right, now we're going to start off by going to the worksheet Define Names. Now, defined names allow you to assign a name to a cell, a range of cells, non-contiguous ranges. We can actually save worksheet formulas or LAMBDA function. Once we save a name for any of these things, we can use that name in formulas and in other areas in Excel. There's also some automatic defined names that are created, and table names are stored with defined names. Now let's look at naming a cell. I want to create a formula here, but instead of referring to B7 for begin and C7 for end, I want to name these two cells, begin and end, and then in the formula, I'll use the names instead of the cell references. Now, the most basic way to name a cell or a range or a non-contiguous range is to select it and go up to the name box. I hover, it says name box. I click. I'm going to type begin and enter. Now, if I click off to the side, I can use the name box as a go-to mechanism. If I select begin, I jump there. Select criteria, I jump down there. Now, up in formulas, define names, well, here's a bunch of cool things we get to access when we're using defined names. The name manager is where you can look at your stored defined names. Now, I'm going to use the keyboard to open that. Control F3. There's our name. We can click Edit. There's the name we gave it. The scope, that's where you can access it. For a cell like this, we can access it anywhere in the workbook. You can also specify a particular worksheet, comments. Now, I added a comment here, but usually for cell references or ranges, maybe you don't add a comment. But when we create formulas and Lambda functions, we definitely want to add comments. And look at this. Down here refers to every defined name, whether it's a cell, a range, a formula, a Lambda, or other. They're all defined by a formula that starts with an equal sign. Now, this is a cell reference. It has equal sign, name of the sheet, and by default, an absolute reference. You can change it, but there's not many good reasons to change it. That means if you use begin in a formula, it's by default an absolute reference. Click OK. Now in the Name Manager dialog box, you click New if you want to create a new defined name. You can come back and edit, and you can delete. In the name column, we have the names of all of our defined names. And that icon right there means an Excel table. The only editing you can do to the Excel table is to change the name or add a description. Also, this icon, that's for a defined name. However, this defined name represents a reusable Lambda function. And here in the Name Manager, we see the defined name icon. But when we type an equal sign and invoke this in a formula, we'll see the f of x icon. Here's the value column. That's a preview of the values. If you have a Lambda defined function, there's no preview. Here's the formula, not only for a particular cell or range, but also for our Excel tables and for our Lambda functions. Here's the scope column. Workbook means it's available everywhere. If it's only available on a particular sheet, it'll list the sheet name. Defined names, that's the automatic name given to the automatic defined names created extract and criteria when you use advanced filter. Now, we don't use advanced filter so much anymore, but just in case you get a workbook and these show up, you'll know where they came from. And then finally, we have the comment column. Now let's click Close. Now we created the begin name for this cell, which we can see up here, by selecting the cell and typing in the name box. But if you have some data with a name above or a complete table with field names at the top, an easier way to create a defined name is to select the name and then the data below it or next to it, and use the keyboard Control-Shift-F3. That is up here. There's a button in Define Names, Create from Selection. But look at that. It knows that there's a number and a name above. So all I have to do is click OK. And now I have a new defined name for end. Now when we make a formula equals end divided by begin minus 1, that's the formula for rate of change, and enter. There we go. We can also equals, and I can use the F3 key. That brings up a list of paste names, and then you can select. I have to use this often when I can't remember quite what the name was. But here I'm going to double click in, divided by, and I could type. And define names and our Lambda functions will show up in a dropdown. There it is, the defined name. I hit Tab. Whoops, that's the wrong one. Begin, there it is, minus 1, and enter. We can also, if we have a table with field names, we used to do this a lot before Excel tables, but we don't do this so much anymore. I can use Control-Shift-F3, and now each one of those columns is going to be named the field name. Uh-oh. It also thinks that I should name each row these names, so I definitely don't want to do that. When I click OK, now I have new product, units, and sales rep. Also, you can highlight non-contiguous ranges. This is for cases like when you have many numbers spread across different locations, and you want one reference for those non-contiguous ranges. I've highlighted them. I'm going to go up and just type test scores. By the way, you can't have spaces and other characters. Now when I hit Enter, I can use test score to highlight, or Alt equals test, and there it is. I can quickly add. Now in these first three examples, we use define names to define a range. The advantage, well, a situation like this, it's obvious. We might have many ranges, and we have a single reference. Also, F2 People like to have words in their formulas so they're easy to read and understand. Now, another great use for defined names is that we can save formulas as defined names and then invoke those defined names in any formula that we use. Now, I create the numbers 0 to 10 all the time. So here's the formula for that. Control-C, Control-F3, click New. I'll name it something like 0 to 10. And we can decide the scope, whether it's a workbook or a particular worksheet. We'll add a comment, something like that. And then down where it says refers to anything that you can put into a formula, you can put into a defined name. Control-V. Now, this is going to generate 0 to 10. In the old days, we used to use defined names to create dynamic ranges. That was before we had Excel tables, we'd have to use index or offset to create dynamic ranges. But any formula you can dream up, you can put into a defined name. I'm going to click OK, click Close. And now I simply have to type the name. There it is, Tab, Enter, and I have 0 to 10. Now, another common task for defined names is here we have a lookup table. And if we use this all the time, we can actually save it as a defined name. And then every time we need that particular table, we just use the defined name. Now, this is a fiscal quarter formula. And we're looking up month number. That's the first column of this approximate match lookup. And we're returning a fiscal quarter where the first day in the fiscal year starts July 1st. So I'm going to click Escape. Down here, we're actually going to create an array constant and save that as a defined name. If I hit the F9 key, there's the lookup table hard-coded into an array constant. I'm going to copy, Enter, Control F3, New. We'll call this something like fiscal quarter lookup table. We'll save it so we can use it in the whole workbook. We'll give it a good description, including that it's an approximate match and what the first day in the fiscal year is. And then down here, Control-V. So we're saving a lookup table as an array constant. Now, this assumes that it's not going to change, and tables like this usually don't change very often. After we click OK, there's our lookup table. And now, from now on, when we need that lookup table, we just type the first few letters. We see our defined name. There's the screen tip. That's the comment we created. Tab, close parentheses, and Enter. Now, using defined names for lookup tables is a great use. Maybe you have a pricing lookup table that you want to save as a defined name. But what if we really wanted to just save this formula? Let's say we have to create this fiscal quarter formula all the time. Well, that's the perfect job for LAMBDA. Now, the LAMBDA function will allow us to create a new reusable function. And we're going to put two things into LAMBDA, and then LAMBDA will create a new function for us. We're going to have to put the formula in there so the new function knows how to make its calculation. And if you look at this formula right here, how many inputs are there? There is only one input, dates. So inside of LAMBDA, we'll say, hey, LAMBDA, the new name of the argument will be date. And then we'll list our formula to define how the new function calculates. Now, as a preview, since when you use LAMBDA for the first time, it's kind of a hard concept, this is the LAMBDA function that's going to define a completely new reusable function. We're going to have to put in what's called a parameter. That's just the name of the argument that will show up in the function. And then in the second argument, we're going to make the calculation. We'll say, hey, that's how we want you to calculate. Now, once we're done creating and testing our LAMBDA in the worksheet, we'll copy the whole thing, paste it up into the name manager, and whatever name we give it. And in fact, we'll name our function fiscal quarter. That'll be the name of the defined name. Once we save it, we can just come to the worksheet, and there it will be, fiscal quarter. And sure enough, the argument that we named inside of LAMBDA, there it is, date. Now, we don't see the formula that we saved in LAMBDA. That's just sitting up in the name manager. defining how this worksheet function works. So there's our argument. We simply highlight the dates, and when I hit enter, bam, we have a new worksheet function we can use anywhere to calculate fiscal quarter. All right, let's delete this and create and test our lambda. Make sure you have this copied. Equals, there it is. I type L, lambda is the first L function, tab. Now inside of lambda, we're going to need the parameters or the formula inputs. Those are the function arguments. And then once we're done with entering our function arguments, then we put a calculation. That defines how the new function will work. We have one input, date. When I type date, that parameter will become the function argument, comma. Now we're done with parameters, so we put in calculation. Control V. Now there's two things we need to change here. One is inside of month, we don't want it pointing to anywhere in the worksheet. We want to put the argument name right into serial number. That way later, when we use this as a function, whatever we enter into date, that will be going into month. So date. Notice that X icon. That means this is a parameter or formula input that we're creating right inside of lambda. The other thing we want to change is I don't want to leave this as a defined name. I want to hit F9. Let's just hard code that in to the function because this is never going to change. All right, close parentheses. For our first example, we have one parameter or function argument, and we have our calculation. Here's the thing, though. We need to copy and paste this up into the name manager. But I want to test it. If you enter it, you get a calc error. And that's because, well, it doesn't know what date is yet. But here's how you test it. Since this is going to define a function, and we'll call it fiscal quarter, what do we do after we type fiscal quarter? We type open parentheses. So that's what you do after the last close parentheses for lambda, open parentheses, enter whatever arguments there are, close parentheses, and that's how you test it. When I control enter, that is working. Now F2, notice we're creating our lambda function in the worksheet. That's one location where you can create lambda functions. You can also create your lambdas in the name manager, but sometimes that's almost impossible. The other way to create lambdas is to use advanced formula environment. The difference is when you create it in the worksheet, you can easily test it by referencing cells directly in the worksheet. You can't do that up in advanced formula environment. Now we'll definitely take a look at this feature because it displays the description and the formula in a way that's much easier to read than over in the name manager. Now when we copy and paste this up into the name manager, we do not want that little bit that we use for testing at the end. Control C. Control F3. New. We'll call this fiscal quarter. We're going to save it as scope workbook, so it's available throughout the workbook. Come down to refers, highlight, delete, Control V. There's our new lambda. However, we left something out. We always want to add a comment because whatever we type here shows up in the function description when we start to type fiscal quarter into our formula. So we'll add a comment. Something like describing what it does, that it needs a date, and also what the first day in the fiscal year is. And there we go. Name, scope, comment, and definition. Click OK. There it is. Click Close. Now we can come over here. Equals fiscal quarter. And sure enough, there's our beautiful new function. Date, I simply highlight a single date or a range. Enter. And bam, we have created our first lambda. Now, we created our lambda in the worksheet and then Control F3 to get to Name Manager and New. That's the way I prefer to do it, especially since I can test it right in the worksheet. But there's an alternative, Advanced Formula Environment. Now, the drawback to this is two things. One is you have to go to Insert and Get Add-in. And look at this. Many of us in entities, businesses, I'm at Highline College, around the world are not allowed to add add-ins. Well, that's not a problem. Just use the define name dialog box. I like it better anyway. However, as we'll see, there's a couple good things about advanced formula environment. So if you can, you just search for it and add it in. It's in formulas over in advanced formula environment. Now I'm going to select a cell with a formula and go up and click, or the keyboard is really easy to remember, Alt-My, M-Y. There's a couple different parts to this. The first one is interesting, grid. Notice it's showing me the formula of the selected cell. Here's that formula, but watch what happens when I click on my fiscal quarter formula. I did not format this, but this dialog box shows it formatted. Now, this formatting for many people is easier to read, and that's definitely a positive aspect of this task pane. Now, we just looked at grids. Let's go over to names. That's for define names. There's 4 sections. We'll look at 3 of them. And here is all of the formulas saved up in the name manager, all of the ranges, and all of the lambda functions. So that makes it pretty convenient to have a different tab for each different type of define name. If we want to look to read and see what the description, name, and formula is, we can click Edit, Name, Description, Formula. I can click Done. Here's the ranges. There's the begin and end, which we named. Product. I can click to look. Name, Description, Definition. Done. Here's the functions. There's the one we just created. Here's a couple of other ones that I already have in this workbook. Here's a regression one. And look at this. If I click Edit, it is much easier to read the function name, the description. It even gives you a preview of the arguments. And here, I did not create this formatting when I typed out this formula. This is done automatically over here. So for reading and looking at the different defined names that you have, for some people, this is the way to go. I'm going to click Done. Now I want to show you just quickly how to create a lambda function in the advanced formula environment. We're in Functions. I click plus. I'm going to call this Junk tab. The description will be junk. And here's something that's very different than how we created our lambda. In the worksheet, you type out the function lambda, and you list the arguments inside of lambda and then the function. Over here, you actually type the arguments here. So the quick function I'm going to create here is just going to have one argument, date. You type it in and then hit Enter. It's listed there. Then down here, you don't put the lambda. You just type whatever the formula is and use the argument. So we have everything we need. We click Done, but then you got to click Save. When I click Save, it's saving it up into the name manager. Now let's click in the worksheet, Control F3, and sure enough, there is junk. It copied everything here. Click Cancel, Close, and I can use it. There's my junk. There's a date. I've converted it to month. Now, if you want to delete it from this environment here, well, let's click the trash can, delete, but then you got to click Save. And just like that, I have a name error. Control F3. All that junk is gone. So I'm curious, what do people think? I don't really use this to create them. Does anyone use this to create them, or do you use the define name box, or what do you think? I certainly like these different tabs here, and I like the fact that it's easy to read the descriptions and the formulas. All right, let's close this. Now, over here on Lambda Notes is a great summary of Lambda. And don't forget, there are PDF notes. Click right here on Define Lambda. It defines it, and then there's that cool picture. Now, here's the arguments. We talked about those. When you create a reusable function, we're going to have lambda, and whatever parameters, then the definition of how the function works. Then you copy and paste it up into Name Manager. That's what it looks like in the worksheet. But creating reusable functions is not the only thing that Lambda can do. Lambda has 6 helper functions like BYROWs. Imagine you wanted to create a formula that spilled row totals. Well, guess what? If you use the sum function and highlight this whole range, it's going to give you one answer because it's an aggregate function. But that's where BYROWs and LAMBDA come in. You can say, hey, BYROWs, take this range right here, and by row, notice the second argument is function. It'll take whatever function you define here and calculate it for each row in the first argument of BYROWs. LAMBDA, R, well, you have to define the variable, and that variable always represents the rows for the array in the first argument of BYROWs. So I always call it R, and then sum R. So that formula can spill row totals. Now, we're going to start off, we're going to create this lambda and a couple others, and then we'll jump over and look at all the different helper functions. All right, let's go over to define name lambda. Now we'll start off with a couple simple formulas, one for calculating the rate of change and another for calculating cost of goods sold. Now both of these calculations are simple, so most of the time we would just type out the formula. But what if you're sending this workbook to someone else and maybe they don't always get it right? Well, we can build a lambda for rate of change and for cost of goods sold. All right, equals lambda, I type L and tab. Now we're going to have two inputs, so I'm going to type begin, comma, and end. Now those are the two parameters. Those will be the function arguments, comma, space. Now we make our calculation for rate of change. And rate of change just means what's the percentage or decimal change in a value from begin to end. Now there's a few ways to calculate this. I'm going to say n divided by begin minus 1. If you want to do the slightly longer formula, equals open parentheses n minus begin, close parentheses, divided by begin, you can do that one also. Now when we close parentheses, Control Enter, well, we get a calc error, F2, because we have no cell references, and it has no idea what begin and end is. Well, we treat this as a function, open parentheses, and we have to do it in the same order when we test. Begin, comma, end, close parentheses, Control Enter, and bam, there it is, 20% or 0.20. If we begin at 900, that'll be minus 33%. Control Z. Now F2, copy everything except for that little N bit. Control C, escape. Control F3 to open up Name Manager. New, we'll call this rate of change. I'm going to expand the lower part of this dialog box. Highlight refers to delete. Control V. And we definitely, well, we'll keep it scope workbook so it's available in the workbook. And we definitely want to describe what this function does. This will appear in the screen tip describing what the function does. Something like this function creates the rate of change given a begin amount and an end amount. Name, scope, description, and formula. Click OK. There it is. Click Close. Now we can type rate of change, and there it is. And there's the description. Tab, begin, comma, end. And just like that, I've calculated the rate of change. All right, our next lambda, we're going to create a lambda for cost of goods sold. And that's a relatively straightforward formula. In parentheses, we say whatever the number of units on the shelf at the beginning minus number from the end, multiply that by value. Now, we're going to try the advanced formula environment again because, hey, this is an easy formula. I'm pretty sure I can get it right without testing. Formulas, there's the button, or Alt-MY. The function name, cost of goods sold, tab, and we definitely want a description, something that describes exactly what it does. Arguments, I'm going to hit tab. We need 3 of them, and in this environment, we type the name, enter. The next variable name, enter. The last parameter or formula input or function argument name will be value, and enter. Now down here, we don't have to add lambda, but we're not going to get to test it. In parentheses, begin minus end units, close parentheses, times value. Tab, we click Done. Remember to click Save. Then we could click in the cell. Control F3. There it is. Cost of goods sold. Edit. And there it is. It did make it up into our Define Name dialog box. Click OK. Click Close. Equals cost of goods sold. And there it is. Our three awesome arguments. Begin, comma, end, comma, value. And when I hit Enter, cost of goods sold. That will be the expense on the income statement matched up against the revenue generated by the product quad. Now, we could definitely do a formula and copy it down, or let's spill it. So I'll say begin, arrow over, Control Shift down arrow, comma, arrow, Control Shift down arrow, comma, arrow, Control Shift down arrow. And this is amazing. When I hit Enter, our beautiful cost of goods sold function is working. Now, for both of these functions, we could put them in a workbook and send them to somebody. Another scenario is, what if we use these all the time and we just want it to appear in the workbook when we create a new file? If we look at our PDF notes, there it is, page 11. I just click. Here's the instructions. That's the folder where we have to save a template. Book.xl, and T is for template, X. You can also have an M. When we save our Lambda function here, and we'll look at this in just a second, the blank workbook button does not open this custom file. But if we open the Excel app and click Escape or use Control N, bam, that new file will have our Lambda function. There's our folder. I've already created this, but you got to create book.xl, T for template, and an X or an M. Now, when you have it here, if I double click and open it, a template, of course, is programmed to create a .xlsx. So if you want to add something, right click Open. Now, I've already added it, but there it is. Now, the trick is this, and I'm going to close everything. Let's click the Excel icon. And Microsoft has everything mixed up in how we open new workbooks. For some crazy reason, if I click blank workbook equals cost of goods sold, it's not there. But when I get to this stage, do not click that. Just click Escape. And then our new Lambda function, cost of goods sold, is there. Also, Control N to create a new workbook equals cost of goods sold. It's there too. Now let's go over to the sheet, Show Formula. And I got to show you my new favorite Lambda that I use in all of my Excel workbooks. Now I built a model here. And when I build a model, I like to document it off to the side by listing not only the actual formulas, but the cell address for each formula. So over here, we'll start our formula. And we'll use a function that's been around since Excel 2013, formula text. When I enter this, there's the formula. But at the beginning, I want the address that that formula lives in. So we'll use the address function. It needs the row number and column number for that particular cell. So we'll start off with row, pointing to the same exact reference, comma. Then we'll use the column function. And then the third argument is important. I want for relative because I do not want dollar signs to show up in my reference. So for, close parentheses. Then we want to join it to in double quotes, colon, space, and double quotes, ampersand. That's the beginning of our formula, F2. But what I really want is I just want to highlight the whole model. So we're going to try this. For each one of the inputs, it's always going to use the same reference. But when I enter this, I get a huge mess of errors and formulas. Now, I really want to remove all the errors and list all of the formulas in a single column. Luckily, Microsoft is so great to us in Microsoft 365 Excel with new functions like toCol. Now, if we just use toCol with the array, that's not what we want, F2, but they gave us this second amazing argument. Now, we're never going to get blanks from our formula, so all we need is 2. When I put 2, it will ignore errors and list it in a single column. That is a thing of beauty. Now, what if we don't have any formulas in our model? When I delete all these, well, TOCOL is delivering calc, Control Z. So since we have just a single error coming from TOCOL, all the other errors were dealt with earlier. I'm going to use if error, there's the value, at the end, comma, value if error. Well, you could put some sort of message like no formulas. I'm just going to use the syntax to show nothing, double quote, double quote. And now at the beginning, we add our lambda. There it is, lambda, Alt-Enter, and we have only one input, reference. Now I can copy this, and everywhere I see that reference, I'm going to Control V, come to the end, close parentheses. Now we can test it. Close, and that's looking good. Let's test it. Highlight everything. F5, that's the go-to keyboard. Special, formulas, click OK, delete. Well, that's looking good. Control Z. I am going to move this over here. And now you copy and paste all of this. Paste it up into Name Manager. I've already done that. And here it is. Show formulas with a single argument. All right, that's our fourth lambda. And now we want to talk about something exciting. If lambda weren't enough, we're going to have lambda helper functions and something called Eta-LAMBDAs. If we click here, here's a description. This is from the PDF notes why we have lambda helper functions, and I'll show you that in just a moment. Here's a list of the lambda helper function, BYCOL, BYROW, a bunch of others, including GROUPBY and PIVOTBY. And then down here, these are the Eta-LAMBDAs that will make our formulas even easier. Now, when we invoke GROUPBY or BYROW in the function argument, we're going to have this amazing drop down so that we don't have to define a lambda, but it will be a substitute for a lambda. And I'll show you exactly what that means. Let's go over to BYROW and BYCOL. Now, we want to figure out why in the world we need helper functions like BYROW. Well, what Microsoft wanted to do when they created dynamic spilled arrays is allow us for every formula we've ever made to spill them. Here's an example where we can't spill it. What if we use the sum function, Alt equals, and highlight all of these? Well, if I want to spill row totals, which means for each row I want to add the numbers in that row, add, put it right there. Well, the sum function is just never going to do it. It's an aggregate function, so it'll take all the values and deliver a single answer. So for this situation and a few others, as we will see, Microsoft invented lambda helper functions. So let's try this by row. And we have an array. We put an array in that has multiple rows, comma. And this is the first time in Excel history that we have an argument in a function that says function. And how do we define functions in Excel? We use lambda. Now, our goal is to somehow create a formula that will add for each row. By rows is going to work with lambda. So I type lambda, and we have to define our parameters or variables and then a calculation. Well, the variable we're going to choose, and I'm going to call it R for row, that R variable inside of lambda automatically works with by rows. So whatever array we put here, that variable will automatically iterate each row and make some calculation, comma. Now we have to make our calculation. And what's our goal? To add sum of R. Close on sum, lambda, by row. And now this formula is the first time in history that we can spill an aggregate total. And guess what? You can put whatever aggregate you want, average, median, max, min. And now when I hit Enter, BYROW and lambda work together to spill row totals. Now, anytime we use a lambda helper function, in this argument right here, we can create any type of formula we want. But the good news is that there's something called Eta-LAMBDAs. And for 16 different aggregate calculations, we can simply indicate in function what aggregate calculation we want, and we don't have to type out and define a lambda. So let's see how to do that over here. Our goal is to spill totals by rows. Here's the array with multiple rows, comma, and this is the dropdown that has our 16 Eta-LAMBDAs. So if I double-click sum, that sum is a substitute for the lambda we created over here. Underneath, the code will do exactly the same thing as the formula we defined over here. That's our formula to spill totals. Control-Enter, and that is beautiful. Now, if our goal is to calculate a column total, well, we can use BYCOL, and then in the function, define our lambda. Same thing, except for I'm going to use C for column, and then sum C. Well, that'll work, but we have Eta-LAMBDAs. BYCOL, highlight. That's the array, comma, and I'm simply in function going to type sum. Close parentheses and enter, and now I have my spilled column totals. Well, if I want an average in each row, I certainly could define it that way. It works perfect. But why not do by row? We're going to highlight, comma, and there it is in the dropdown. Average. That is a substitute for the lambda we just created here. And in fact, the first year or so of lambda, we didn't have these Eta-LAMBDAs. And so we had to define everything with a lambda. But now we have an Eta-LAMBDA. That average, bam, each row gets a row average. All right, now in these examples, we were able to use Eta-LAMBDAs. Not all formula spill situations will allow us to do Eta-LAMBDAs. And let's see an example where we have to create a lambda. And let's see another function map. Actually, the way by row works is by row works over each row. BYCOL over each column. Map is going to be similar, but we're allowed to enter multiple ranges, and it will work cell by cell. So let's click. Now we're going to jump back to MECS video number 7, where we talked about logical tests. Now we have a student table here, and we need to check based on 2 hurdles whether the students are eligible for a scholarship. F2. Well, back then we used the AND function with relative and absolute cell references. And the AND function is an aggregate function, which just means no matter how many logical tests we put in, it's only going to deliver a single answer. So you cannot spill an AND function. Well, back in video 7, we used a Boolean logical test to spill the results. 0 was false, 1 was true. But what if you really do want to spill the AND function? Well, we can use the map function. Now, what's convenient about map is there's array. The second argument says lambda or array. And here it is. We have to check 2 columns. We can't do that with by row function. But with map, no problem. So array 1 will be credits, comma. GPA will be the second array. Now, comma. Now we need a lambda, so L tab. And we have 1, 2 arrays, so we need 2 variables. I'm just going to call this one C for credit and the second one G for GPA. So C, comma, G. Now these 2 variables, C and G, are different than the R that we used in BYROW and the C that we used in BYCOL. R represented the entire row. C represented the entire column. I picked C and G because they're descriptive of the columns, but those 2 variables represent the cells in the 2 columns. What that means is that whatever function we end up putting here, lambda will run it through each cell in both of the map arguments, comma, and now we can make our calculation using the AND function. I want to check every cell in the credit column, so I'm using the variable C. Are you greater than or equal to the hurdle, comma, and we're checking the variable G, which represents each cell in this GPA column. are you greater than the hurdle? Close off and close off lambda, close off map. And when I hit enter, there's my spilled and logical test formula. Now let's go look at our second example on the sheet, map 2. Now our goal is to calculate and spill total commissions for each one of the sales rep. And in this example of LAMBDA helper functions, we're going to compare BYROW and map. Because look at this. We could do BYROW for this because there's rows. We could also use map because we're looking at a series of cells. Now we're going to start off by building the formula from inside, and then I'll put BYROW and map on the outside. And in this situation, it's a very specific setup. We have sales rep, products, and these are the different commissions. Then we have sales rep, product, and sales. So somehow in a single cell, I'm going to have to get all of the sales for Sue, but I'm also going to have to break apart internally the sales for Sue based on Quad, Carlota, Aspen, and Yanaki, and then use these different commission rates. Now this cool formula came from GERT. Now we're going to start off with sum ifs. Here's the sum range. Control Shift down arrow, Control backspace, comma criteria range. Well, we'll do the easy one first. So that's got all the criteria. And for the time being, before we use BYROW and map, I'm going to click on a single cell. Right now, this will give me all the sales for Sue. But I need 4 different amounts for Sue, comma. So criteria range, we'll put in product, Control backspace, comma. And one of the keys to this whole setup for criteria 2, I'm going to put in product names directly from the column headers in our two-way lookup table. Close parentheses. If I hit F9, those are the 4 sales amount for Sue, Quad, Carlota, Aspen, and Yanaki. Control Z. Now all we have to do, since the product sales amounts are already in the right order, I'm just going to look up based on Sue the whole row, and the commissions will be in the right order. Times XLOOKUP. There's my lookup value, comma. We're going to try and get a match here. This will tell me the row number, comma. Return array. Well, if I give it more than one column, when it finds the correct row number, it will return the commission rates from the row, and they're exactly in the correct order. When I hit F9, those are the 4 individual commission amounts that I now need to add. Control Z. Well, I'm adding, so I'm going to use sum. Close parentheses, Control Enter. And that's the correct amount for Sue. F2. Now, how do we apply this to BYROW and map? Well, first, realize that this is an aggregate calculation that I need to spill. So I need to use one of these helper functions. I'm going to start off by using BYROW. The array, well, here it is. 4 items, comma. And for function, we use L tab. And I'm going to use R because we're dealing with each row. And now all I need to do is come inside the formula, double click where I had a single cell reference, and put the variable R. Same with right here. This is the lookup value, R. And you got to be kidding me. Close on LAMBDA, close on BYROW, and bam, I've spilled the total commissions. Now F2, I can highlight this, copy. Down here, F2, Control V. I just double click, change it to map. Now we can use map with just a single array, no problem. We'll use the same variable. That formula will spill. When I hit enter, there's the same commission amounts. So in a situation like this, you can use either BYROW or map. But when considering whether to use BYROW or map, there's a gotcha that our teammate Excel LAMBDA discovered. If we look at this formula using BYROW, there's an expanding array inside the LAMBDA helper function. If we look over here, this is what it looks like as the helper function iterates over the numbers 1, 2, 3. We get 2 cells, 3 cells. And because BYROW can only deal with a row, it's only grabbing the first one. But map has no problem because it goes cell by cell. So as map takes the same exact formula, concatenating 1, then 1, 2, then 1, 2, 3, it delivers the correct result. So when you have an expanding array inside your formula, use map, not by row. And Excel LAMBDA takes it a step further. He says, hey, look, since there's this risk, anytime I have a single column, I'm not using by row. I'm going to use map. All right, let's go check out our next LAMBDA helper function, scan. Now, before we look at LAMBDA helper function scan, let's recount what we've done with LAMBDA helper functions. By row, iterates over rows and makes some calculation row by row. By column, iterates by the columns, makes a calculation for each column. Map iterates over an array and makes a calculation for each cell. So if one of Microsoft's goals with LAMBDA helper functions is to cover every scenario so we can spill any formula, what about this scenario? We have a checkbook balance here, and our goal is to create a running total. Now we have an array of change values, and we have an initial value. Now when we create a formula in Excel, it's easy because we have relative cell references. Equals the first item in the array plus the initial value. Now what's important about that is that that's a relative cell reference that always looks one cell above. Now when I enter this, copy it down 1, F2. Now the formula is looking at the second value in the array. It's looking at the previous value, but guess what? That's the value from the array that's being created. If I do this one more time, F2, it's got the third item in the array, but it's looking at the previous value in the new array that's being created. That's exactly what scan does. If we say, hey, scan, we're going to give you an initial value, and we're going to give you an array of values. We tell scan what operation we want. In our case, we want to add, and scan will do the rest. We're going to put into scan the array, the initial value, and it will build a formula that goes cell by cell through the array, always getting the previous value as if it was a relative cell reference. In fact, I think of scan as the LAMBDA helper function that allows us to have a relative cell reference one cell above. Now we're going to use scan and create this formula the long way, that is defining a lambda, so we understand how this particular calculation is working internally, and then we'll use an Eta-LAMBDA. Initial value, where there it is, comma. The array to iterate, those are the changes as we get a running balance, comma. Function, lambda, and we have two parameters, initial and array. So I'm going to use I, comma, a. Look at that, it capitalized, comma. And for our calculation, well, what are we doing? Initial plus a. And that's our formula. Close on lambda, close on scan, and enter. And there's our running balance. If we use an Eta-LAMBDA, there's initial. Those are the values we're going to iterate to get a running balance, comma, and the function, I'm simply using eta sum. When I enter, there's the spilled total. Now in this case, instead of a running balance, we're going to do a running total. And we don't have an initial value. We just want to add these as we iterate down. So guess what? The initial value is 0. There's the array. We use the exact same lambda. That will spill. Well, let's use an Eta-LAMBDA. The initial value is 0, comma. There's the values we want to get a cumulative or running total for, and then sum. I love it. When I hit enter, Eta-LAMBDAs are amazing. Now, whereas scan iterates and gives you each intermediate value, there's a related function to scan called reduce. And reduce iterates, making some calculation, but only gives you the last one. Now let's look at a silly example. Well, the initial value is going to be 0, comma. Here's the array, and the function is going to be sum. Well, if it's true that reduce iterates and only gives you the last one, this is all it's going to give us. So there it is. Now, of course, we wouldn't make this calculation. We would Alt equals, and simply add these. But there are some great uses for reduce. You just want to realize that scan and reduce are related. Scan gives you all the intermediate values. Reduce gives you the last one. So let's go over to the sheet reduce. Now our goal here is to take this alphanumeric value and remove all the number digits. Our result should be this. Here's a formula that works, but we cannot spell it. Now before we look at the reduce solution, I want to go over to the sheet recursion, because recursion is an important topic we got to talk about that Lambda allows us to do. Now over to the side here, before we talk about recursion or reduce, we want to talk about the action of looping, because here's our text, and here's each one of the digits we want to remove. So if we take 0 and jump over here and say, hey, I need to remove 0, well, it will remove that 0, but then we need to go back, get the next character, which is 1, and loop back. We need to keep doing that, getting 2, looping back, 3, looping back, all the way to the end till we ask the question, hey, 9, are you over here? If you are, remove it. Now, before we define what recursion is and look at reduce, let's just see if we can build a solution right in the worksheet using normal formulas. Now, I didn't set this up right. I'm going to move this right above. That way we have the text to start with and the characters we want to try and find and remove right next to each other. Now we're going to have two formulas, one in this column, one in this column. Let's start with the substitute function. Now we want to look at that text, comma, the old text we want to remove. Well, remember, we have to loop through and get each one of the digits here. So I'm going to say the left of this. If I say left 1, it'll get just the 0, and that'll be the first character we check for. 1 is the default for number of characters, so I don't have to put anything in, comma. And the new text, we use the syntax for nothing, double quote, double quote. And when I tab, sure enough, it went and got the 0, jumped over here, and replaced it with nothing. Now, if we loop back over here, the problem is we have too many characters. So the second function will be right. There's the text, and we want everything except for that leading 0. So from the right, we use the len function. That tells me exactly how many characters there are. But I want from the right, -1. Close parentheses, Control-Enter, and we've accomplished our task. We remove that 0. Now, with 2 formulas, we can simulate the looping. Copy them both down all the way to the bottom. And each time, this is getting smaller, always taking from the left 1 character. That 3 right there is removed. And bam, all the way down, looping until we get the final answer. All number digits removed, left with quad. Now, when you have a loop like this, you have to have something to turn it off. And what's the condition that allows us to turn it off? Well, characters to remove has no characters left. Or, as we'll see in our if formula, we just construct the logical test. Characters to remove, that's all the items in this column as we loop through, equals to double quote, the syntax for nothing. Now, this is just looping. We got to talk about recursion. And here's a new concept for most of us. And actually, it's a new concept for me, too. Recursion means that a function can call itself and is allowed to iterate over a value until a task is achieved. Now, the function that we're going to create using Lambda is actually going to contain both 1 and 2 different formulas. And if we look down here, here's the final Lambda. This is the actual name of the function. And notice inside remove car for characters, substitute and write. But here's the crazy thing is that this whole Lambda, when we copy and paste it up into define names, it's going to be called remove car. Now, when we type remove character in a cell and try to use it, it'll ask for text and characters to remove. That'll be the text. That'll be characters to remove. The if will start the loop. And when it finds that there's nothing left, it will deliver the final result, which is whatever we started this text with as the final result. Otherwise, the value if false, that's going to be the lambda function that we're calling within the very same function. And notice what it does. Remove characters. Substitute is going to be acting on the text, transforming it to its final bit of, in our case, quad. And write will be acting on characters to remove. So it'll be transforming characters to remove until it equals double quote, double quote. Now, let's see how to create this. We're going to come down here, equals lambda. The first argument will be text, comma, and then characters to remove. That'll be our second parameter or variable or function argument, comma, Alt-Enter. Now let's do the if characters, and I can see in my dropdown that x means this is a variable. When that equals to double quote, that's the logical test, comma, the value if true, Alt-Enter. Well, it's going to be the text in its final form, and I want to make sure that all extra spaces are removed, so we'll wrap trim around it. All right, so that's the value of true. That's after the loop has stopped, comma. The value if false. This is where we call our function. Alt-Enter, remove character. And when we copy and paste this up into define names, I'm going to double click and copy this, and that's going to be the name of the function. Now, if this is the name of the function, it has to have both of these arguments, text and characters to remove. So I open parentheses, and what do we want for text? The whole substitute bit. We're trying to transform the text, comma, left of the characters to remove. The default is 1. So left is the old text. New text, double quote, double quote. Now when I close on substitute, that's the first argument right here, comma. Now we're going to do characters to remove. Remember, that's just this column over here. Alt-Enter, right. And I'm transforming the characters to remove. Number of characters, len of the same characters to remove. That's always one too many, so we'll subtract 1. When I close on right, that's the second argument right here, characters to remove. So now this function, we close it off. There's the function sitting in value if false, close off if, close off lambda. And here's the crazy thing about recursion. Well, I'm going to Control Enter, and there's no way to test it in the worksheet. So you have to paste it up into the dialog box and hope that it works. And if it doesn't, you have to work back and forth. All right, let's try this. I'm going to copy everything, Control-C, Enter, Control-F3, New. I'm going to come down to Formula first, since I'm such a bad typer. Delete, Control-V, and now I'm going to double-click that so I spell it right. Copy, and this is going to be the name of our new function. Now we want it in the workbook. We're going to definitely add a comment. Something like this function uses recursion to remove the specified digits from a text string. Now I'm going to click OK. Click OK. We're going to try this new function. There it is, remove characters. There's our two arguments, text, comma, characters to remove. There it is. And when I close parentheses and hit Enter, it's going to simulate this looping process using recursion. Close parentheses, Control Enter, and that is amazing. F2, I can definitely spill it. And this you can actually type in double quotes or have some cell reference. Now it spills the results. Now, another amazing thing about this formula that we created is we're not limited to the digits 0 to 9. I can type anything here, quad 635, and now the function will look at these letters one at a time, look through the list, and remove all those characters. So when I hit Enter, just like that, we've removed all the characters from here, and here's the result. Now, we used recursion and a loop. And one of the reasons we did that is because we put all the characters into a single cell. And that required that we looped back, peeling off each one of the first letters and checking it against the text items. But rather than put all the characters into a single cell and looping using recursion, if you have the very same characters in the cells in the worksheet or as elements in an array, we can iterate over this array using the reduce function, using substitute only, and we'll accomplish the same goal. Now, in the Excel worksheet, if you know the number of iterations, which we do, we just count the number of characters, you can use the reduce function rather than recursion to call the function for each iteration. So again, we'll just run this over the array of letters, and that formula right there will calculate at each point in the array. When we get to the very last item, that means all the characters are removed. That's what we want. And that's the perfect job for reduce as opposed to scan. If I escape, this is what scan would deliver. That means each intermediate values. But reduce does every single action, but only returns the last item. And that's exactly what we want. Now, I did want to show you recursion using Lambda, because this is the first time in Excel worksheet history where we've been able to do this with a worksheet function. And if you don't know the number of iterations, this is the perfect solution. Now, I want to go over to the sheet reduce. We're going to look at 3 lambdas that use reduce. And the first one here, all we want to do is remove numbers from a text string. Now, the way it will work is this. We need to create the array 0 to 9. We'll skip over rows. There's 10 digits, comma, and we want to start at 0. Control Enter. That gives us 0 to 9. The formula is going to be substitute. Text, well, that's going to be the initial value, comma, the old text. That's for each iteration in the array, comma, and we're going to replace it with the syntax for nothing, double quote, double quote. Control Enter. And this will simulate the iterating that reduce will do. If we were using scan, it would deliver each intermediate value. But the beauty of reduce is it only delivers the last one. All right, let's build our lambda. Actually, let's first just build the reduce, and then we'll add lambda in front. Equals reduce, the initial value, that's the text, comma, the array, we have to create that sequence, starting at 0 and going to 9, comma. Now we have to build a function to iterate over 0 to 9, L tab. Lambda has to communicate with reduce, initial value array. So I'm going to use the variable I, comma, A, comma. And our function, of course, we're going to use substitute. The text, that's the initial value, comma. The old text, just as we did over here, iterating over 0 to 9. So that's the letter A. And our new text, double quote, double quote. Close parentheses on substitute, close parentheses on lambda, close on reduce, Control Enter. And that is looking good. F2, let's actually trim this to remove the extra spaces. Close parentheses, Control Enter. F2, we can make this a little bit easier to read. Alt Enter, Alt Enter. Now to convert it to lambda, L tab, we have one function argument, text, comma, Alt Enter, and a double click. This is where we put our one input. Close on lambda. Now we can test it. Here's all the text. Close, Control Enter. Bam! That is looking beautiful. Now you copy and paste everything but that last little bit up into the name manager. And I already did that. The name of the function, at least the one I gave it, was remove numbers from text. Here's all the text, close parentheses. And when I enter, now we have a beautiful new function for any time we need to remove digits from text. Now, this is very specific, but what if we wanted to have the freedom to specify all the characters? Well, we'd have to use recursion here. So how do we get that into an array? We can use the mid function. Now, the mid function is programmed. If I say character 4 and go 4, it'll get quad. So we want this text, comma. And the trick is we want a starting number for every single character, and then the number of characters to extract, 1. So here we use sequence. And for rows, we say whatever the length is. So that'll give us 1 to whatever the length of that is. Close on sequence. That'll deliver all the starting numbers, comma 1, extracting a length at each starting position of 1 character. And that will do it. That will extract whatever we put up here. So if I put the characters to specify, bam, that is dynamic. Control Z, F2. Now, that's the array inside of reduce. Reduce, initial value, all of these, comma. There's our beautiful array that we just created, comma. Function, well, guess what? Our lambda function is exactly the same as above. Lambda, initial value, comma, array, comma, and the formula is substitute. We're going to start with the text, whatever the initial value is. Old text for each element in the array. Well, that's the variable a, comma, new text, double quote, double quote. Close, close, close. And when I Control Enter, that is looking beautiful. So really, the only thing we did different is we had to be creative and create an array from text entered into a cell. Now we have 2 inputs if we're going to convert this to a lambda. Text, comma, characters to remove, comma, Alt-Enter. I'm going to close this off. Double-click text, copy. We'll put that into initial value. Characters to remove, that goes in 2 places. Text in mid and len. Now we can test. Here's the text, comma. There's the text we're specifying. Close parentheses. Control Enter, and bam, our new lambda is working. Now copy and paste. I already did that. Equals, and I called it, there's the one for recursion. I called it remove char R for reduce. Here's the text, comma, here's what we're specifying. Close, Control Enter, enter a bunch of characters, and bam, instantly our functions are working. Now here's another great lambda, and actually both of these cool lambdas came from, you guessed it, Excel LAMBDA. Our goal here is to find whatever capital letter there is and insert a space before. This is going to require that we use the character function. And you have to know that 65 is capital letter A. 65 plus 25 will give us Z. So the array we're going to need inside of reduce, well, we'll use character, and then we'll use sequence, comma. There are 26 letters, comma, and we need to start at 65. When I enter this, that is beautiful. Now, when we iterate, what are we going to do? We're going to hit each letter. When we come to C, it's this point in the array. It'll see C, take it out, and we'll say, please put in its place C with a space before it. The beginning part of this lambda is exactly like the one we did up here. We'll have 1 parameter, text. We'll have to trim. And in reduce, there's the initial value. The array, Alt-Enter. We'll use A to Z, comma. For the function Alt-Enter, it's going to be exactly the same as this one up here. Initial value I, array A. And inside of substitute, there's the text. We're going to start with initial value. Old text is whatever point we are in the array. And watch this. The new text is a space joined to, hey, we're going to pull it straight from the array. Close, close, close. A bunch of closes. And now we're going to test it. Close parentheses, Control Enter. And bam, just like that, our 2 caps C, they get spaces. Now, I already copied and pasted this up into the name manager. And you know what? I forgot what I called it. No problem. I'm going to type an equal sign and hit the F3 key. We saw this earlier for defined names, but I can use it for a function. Oh, that's what I called it. Space before caps. Click OK. Open parentheses. There's the argument text. Close parentheses, Control Enter. And now I have an amazing new function to insert spaces before caps. All right, all together, what do? We talked about scan. That always gives us each intermediate value. We talked about recursion before we talked about reduce, but that's an important topic. Then we did reduce, where instead of giving us all the intermediate values like scan, it only gives us that awesome last one. All right, now we want to go talk about another Lambda helper function, MAKEARRAY. Now, I'm not going to spend much time looking at MAKEARRAY. I'll leave a couple examples here, and there's one over here. But here's how it works. MAKEARRAY, you have to tell it how many rows you want in the resultant array. I'm going to say I want 5 rows, comma, 6 columns. And then you build some Lambda function to work across the 5 by 6 rectangle. Now I'm going to do a silly one here, lambda. And it makes sense to call this row argument R, comma, the column argument C. And guess what? I'm just going to spread x's across this rectangle array. Close parentheses, Control, Enter. If I think love is the most important thing in the universe, I just put love in all the cells. Here's an example up here, 5 by 6. And each row, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, are multiplied. So row 2 by column 3 is 6. Now to summarize, remember by row takes a lambda and works on each row. By column works on each column. Map works cell by cell. Scan takes a lambda pointing at an initial value, working across an array as if there was a relative cell reference, delivering all values. Reduce does the same thing, but delivers the last value. And MAKEARRAY allows you to make an array specifying a row, a column, and a lambda. Now we want to switch gears and talk about the amazing LET function. Now, before we look at an example, here's some notes about LET. The LET function allows you to define variables within the LET function and use those variables to make calculations. You use LET when you have repeating formula elements or when you want to make a complex formula easier to read. The advantages of using LET. Well, the variable, which is a formula element that is repeated, it is evaluated a single time. That result is stored in memory, and it can be used throughout the formula. That means it speeds up how fast a formula can calculate. Also, formulas with repeating elements are much easier to edit when it's only located one place in the formula. Also, complex formulas can be visually easy to read because you get to name each one of the formula elements. And it makes condensing reports made up of multiple formulas into a single cell formula that spills the complete report. Now, the next 2 Lambda helper functions we want to talk about are maybe the best ones ever, GROUPBY and PIVOTBY. Now, at the end of 2023, these were in beta. These come out into all of Microsoft 365 in early 2024. And both of these functions, GROUPBY and PIVOTBY, they basically make pivot tables. Let's try GROUPBY to make a regional sales report equals GROUPBY. There it is. Row fields, that's the conditions or criteria in the row area. And I'm definitely going to highlight a field name, comma, the values, well, sales, including the field name, comma, the function. Well, guess what? We get to use an Eta-LAMBDA. Now, if I enter it as just that, we get just a unique list, the summarized values, and a total row. F2, backspace. But there's some other wonderful arguments. We have field headers. No means your data set does not have field names and you don't want to use them. Yes, it has field names, but you don't want to show. No, but generate. That gives you a ridiculous label. And then yes and show. That's the one we want. Control Enter, and there's our regional sales report. Now F2, backspace. There's some other great arguments. Total depth. We can have grand and subtotals. We can even have them at the top when we have more than one field in the row area. We'll look at that in just a moment. Now sort order is great. You count from the report 1, 2. If you want to sort the second column, you type a 2. 2 will give us A to Z. Control Enter. ascending, F2. And if we put minus, that's descending, biggest to smallest. And there we go. F2, there's one other argument. Just as in a pivot table, you can have a filter that filters all the values. We can include a filter. We could say, hey, and I'm not going to include the field name, region, are you not equal to West? And this argument right here is exactly like the argument in the filter function. Close parentheses, Control Enter, and now West is gone. Control Z. I'm going to leave the West in, sorted on the second column. Now, if we look at the PIVOTBY function, PIVOTBY and GROUPBY are almost the same. Now, looking at the arguments for PIVOTBY and GROUPBY, the first row fields exactly the same. Notice column fields is in PIVOTBY, but not GROUPBY. Then we have values. Then we have function. Then we have field headers. So far, all the same except for column fields. And then total depth in GROUPBY. Notice because we have row and column, there are 2 total depths in PIVOTBY. Sort order, there are also 2 sort orders inside of PIVOTBY. And finally, filter array, exactly the same. That means everything you learn about GROUPBY applies to PIVOTBY, and everything you learn about PIVOTBY applies to GROUPBY. All right, so let's make the same report using PIVOTBY. So for the row area, we're going to highlight region, including the field names. We're going to skip over columns, the values, sales, comma. And for function, we'll put Eta-LAMBDA sum, comma. Field headers, I have some, and I want to show, so I'm going to use 3. Comma, we don't have 2 fields in the row area or the column area. So I'm going to sort row, second column with a minus in front, so it's biggest to smallest. And there's the exact same report. Now, for both of these, I already added some bold on the label and some number formatting. Now, here is GROUPBY. Of course, that Eta-LAMBDA is a substitute for that. And we're glad we have this new LAMBDA helper function, GROUPBY and PIVOTBY, because this is how we used to have to do it. So it's just a lot easier now. Now, why would you ever use formulas? Well, pivot tables are what we use most of the time. But when your project requires that the result instantly updates when something changes, that's when you use formulas. And there's lots of examples everywhere. In fact, on the next PIVOTBY, I'll show you a great example. Change the data, instantly update. Control Z. Now, one problem, and Microsoft should fix this, is there's no label there to say what the calculation is. So here's a GROUPBY, and I'm going to use 3. And sure enough, it says region. But this is a problem right here, because this is average, F2. So there's a couple ways we can solve this. One is I already put the labels up here. So I'm going to say yes, but don't show. So that's 1, close parentheses. Probably even better is I'm going to edit this. I'm not going to even highlight the field names. So I'll change this, and then change this to 0. That's one way. Let's take this exact same report right here with that 0. In the next formula, we're going to use VStack and just create our own labels inside the formula. So for array 1, those will be the labels in the first row. Array syntax, curly brackets, in double quotes, region. We want it to go across the column. So in array syntax, we type a comma. And then something like average sales and end that curly bracket. Comma, array 2, I'm simply going to Control V, close parentheses, and bam, that's much better. I would never make a report, a formula report like this, without some indication at the top what that calculation is. Now, I have freeze pane, so I'm going to scroll over. And we want to see how to add 2 fields to the row area, have 2 calculations, look at subtotals, and conditional formatting. We'll use GROUPBY, row fields. Before we had 1, now we're going to have 2. And actually, let's not include the field names. So we have 2 conditions in the row area. Comma, for the time being, I'm just going to put sales. Comma, the function is going to be average. comma, and this is where we want 0. We don't have field names in our range, and we don't want them in our report, so 0. And let's just see what this gives us. Control Enter. And sure enough, 2 fields. So each one of these calculations is based on 2 conditions. The record and the sales have to be Midwest and Ahmed. Now notice we have totals but no subtotals. F2, backspace, comma, the total depth. I definitely want grand totals and subtotals. You can put them at the top also. 2, no sort, no filter, close parentheses, Control Enter. And there we go, the East total, Northwest total, and a grand total at the bottom. Now F2, let's add 2 fields for calculation. We're doing sum, so both fields will get a sum. Control Enter, and now we have 2 conditions and 2 different calculations. We're doing an average on sales and cost of goods sold. This report is useless because I have no idea what those numbers mean, so we're going to use VStack, Alt-Enter, comma, and in the first array, we'll build using array syntax our field names. So I entered everything into array syntax. I have the comma. I come to the end, close parentheses, Control Enter, and that's a beautiful report. Now let's add some conditional formatting. Now the first thing we want to do is for the first row, I'm just going to add bold, Control B. Then for the rest of the rows, I want to highlight and make sure I highlight enough rows below to accommodate any new data. And I'm looking at this report here, and I'd like to add bold to the subtotal row and bold and double underline to the grand total. Now the pattern we're going to use to apply this, at least for the bold for the entire row, is, hey, subtotal and grand total rows have an empty cell in the sales rep column. So we go up to Home, Conditional Formatting. There's no built-in formatting for this, so we do New Rule, and we'll use a formula. And the formula we're going to use, well, first, we're going to make sure that the active cell is in the upper left corner, because whatever formula we create here, in memory, it's as if it gets copied over and down. Every cell gets either a true or a false, format or don't. So very carefully, I'm going to click on the sales rep column in the first row, because the active cell is right there. And I need to lock the column and not the row, so I hit F4, F4. Now that S column is locked when the formula copies across the columns, but the 6, when it copies down, it's allowed to move to 7, 8, and so on. And we want to say equals double quote. That'll be the syntax for an empty cell. Now we come over and format, and all I'm going to do is font, bold, click OK, OK, and sure enough, that is working. Back up to conditional formatting, new rule. Let's do a formula, but this time we want to look at region column. So I'm going to select that cell, F4, 1, 2 times, lock the column, but not the row. And I want this formula as it goes down to look for grand total. So when that's equal to grand total, then I want format, font, and a double underline. Click OK, click OK, and sure enough, that is working. If I add a new region, bam, just like that. Every subtotal row has bold, and that grand total row, jump to the next row here with a bold and underline. Control Z. Now notice when we did these 2 calculations up in our formula, we did average, and it applied it to both columns. Now I don't know a built-in way to get different calculations, but we can certainly create a report and then use HStack to add an extra column. Now I added labels at the top, and I already started group by with a sum. And I want % of sales as an extra column. Now you can use group by and % of. That's one of the Eta-LAMBDAs. But I'm going to take a different approach. I want to define this as a variable inside of let. Then guess what? To calculate percentage, I'm going to drop the first column so I get all the values. Those would be the numerator. Then I'm going to take from this column, I'm going to take just the last row, and then we'll divide. F2, Now, let is great when you have repeating formula elements, and I'm going to use this multiple times. So we'll call this G, comma, end, comma, Alt, Enter. And I'm going to grab the sales. S will be the name. And I'm going to drop from an array, that's G. I want to drop the first column. So that gives me the second columns with the numbers. Now, we don't want to drop rows, so I'm going to comma. And from the left is +1. If I was dropping something from the right, I'd use negative numbers, 1. Now, when I build a let like this, it's hard to test it. So what I like to do is Alt equals. And right now, we have 2 variables. And I want to test a calculation, so I'm simply going to type S and see if that worked. And sure enough, it did. Now, the next variable is going to take S and take just the last value. That will be the denominator for every one of these values. F2, backspace. I'm going to use T for total, comma, take from the variable we just created, S. And I want to take rows from the bottom, so -1. Close, comma, Alt-Enter T just to test it. And sure enough, that is working. F2. Now, the last calculation is simply going to be H stack. We want to, in array 1, put G, comma, and array 2, S, that's all the numbers, divided by T. That's just the total. Close parentheses. That's the formula. Close parentheses. And let delivers the result. Now, I already pre-formatted it. But there you go, 2 calculations. Now, next, we just talked about lots of group by. And everything we learned here works in pivot by. But let's go over to pivot by. Now, to see how pivot by works, let's do a cross-tab sum of sales based on region and product. So rows, highlight the field, Control-Shift down arrow, Control backspace, comma. Column fields, I'm putting in product. Comma, values, I'm going to put in sales, comma, and there's our edit sum, Control Enter, and that is amazing. A full pivot table report with a simple formula. If you go and look how we used to do it in the old school days, that is crazy. Pivot by does miracles with formulas. Come back over here, F2. Now there's some other arguments. Comma, I definitely want to show fields. So I'm going to use that 3 tab, close parentheses, Control Enter. That's much better. Region and product. F2. Now, comma, row depth. That's if you have multiple fields in row. We don't, so comma. Sort row, I don't want to. Column depth. That's when you have more than 2 fields in the column area. Column sort. If you put a 1, which is the default, it goes smallest to biggest. But if you put -1, it'll go biggest to smallest. So we have Yanaki to Carlota. F2. And, comma, there's a filter just like in group by and just like in the filter function. So let's say we want to look at West without the field name. And I want to say not equal to West. Close parentheses, and that is a pivot table without West. Now, Control Z to get rid of the filter and Control Z to get rid of the sort. I'm going to take this formula right here, copy, and I want to do a little analysis. F2, Control V, and put an equal sign at the beginning. What I'd like to do is, based on past data, look at an increase of different percentages. Now, there's a couple ways we can do this. One way is we can actually just multiply. Here's the sales column right here, 1 plus that 20%. Now, this will make a calculation for every single row. So if it's a big data set, it might take some time to calculate. But 1 plus this percentage, close parentheses. So we're actually making an array calculation right on values. When I Control Enter, sure enough, there's the increased amount. 15%, 30%. Automatically, our what-if analysis is made easy using a pivot table and a formula input. Now, let's copy this. There's another way we can do this. Control V. Instead of multiplying by every single row, we could actually summarize first and then multiply by many fewer values. So comma, The function, we're going to use lambda. The variable, I'm going to call it C for cell, comma, and we're going to sum. That's C. And now we multiply 1 plus whatever the increase is there. Actually, it could be a decrease too. And that's our calculation. Close parentheses, Control Enter. We get exactly the same thing. Minus 15%. That means 85% of total sales. That's what this represents, or a reduction of 15%. Now, let's see something cool about this. What if, and I'm going to change it Control Z back to 30%. What if we wanted to what if and not change this all the time? I just want to know what the percent is that gives me 75,000 grand total. And then I can look at the individual amounts. Well, you know what? We're going to use goal seek. And for the life of me in Microsoft 365, I can't find it anywhere. But luckily, I know the keyboard from all the way back in Excel 2003. Alt-TG for Tools Goal Seek. And the beauty of Goal Seek is I can set this particular cell to a value, 75,000, by changing what? The percentage increase. When I click OK, it iterates and finds exactly 75,000. So we have to have a 90.34% increase to get to our 75,000 and all of our individual numbers. Cancel. I sure am glad we have PIVOTBY. We can do so many amazing things. Now, the last thing we're going to do with PIVOTBY is going to blow your mind. We want to be able to change whatever inputs, change the calculation, and have everything update. Filter column is region. We're going to change it to west. And bam, just like that. I like to see a pivot table do it that fast. Now, before we build our report down here, I want to work on the control area up here. These are going to be our formula inputs. For each one of these cells, I've added data validation. Data validation. So for the row, column, and filter column, I've added this data validation. So we're only going to pick from these columns. For the sales, I'm only going to pick from these two. This function right here, we're going to pull from this list. The only problem is if I change this to region, I need the drop down here to change. So I actually want to build a data validation list that will change based on whatever the filter column field name is. So we're going to use the XLOOKUP function to look up an entire column. And in fact, most of the tricks in the PIVOTBY formula we're going to create use XLOOKUP to look up columns so everything can be dynamic. So we're going to look up region, comma, within these field names, comma, and when I highlight multiple rows, when it finds a match, it'll return the whole column. So I'll highlight all the way down. So return array has those columns, close parentheses, and sure enough, it's looking up all the items from region. If I change this to sales rep, that is working. Control Z. I really need a sorted, unique list. Close, close. And so that will work. There's the sales rep. Here's region. Now we select this cell, and we want to point to this dynamic spilled array. Alt-DL, Tab, L, Tab. And instead of highlighting the whole range, I simply select the top cell and use the spilled range operator, pound. Click OK. And so there's region. When I change this to sales rep, that is a new drop down. So we'll change it to region and west. Now inside PIVOTBY, since we're selecting columns, row fields, columns, values, and filter array, those all need to be XLOOKUP to look up columns based on the conditions. So for row, XLOOKUP, I'm looking up that within these three field names and using all three columns. Return array, close parentheses, and comma. Now I'm going to copy all of that for row, Alt-Enter. For column, Control-V. I just have to change the lookup value to product. And I have that XLOOKUP saved, so when we get to filter, we can paste it. For the calculation column, we're going to look up this comma within here, comma, and select these columns. Close, comma. Now let me Alt-Enter, Alt-Enter. So for function, Alt-Enter, we're going to put a placeholder. We'll come back to that later and make it dynamic, comma, Alt-Enter. For field headers, we want to show the field headers, comma. We don't have multiple items in the row. We don't want to sort, so comma, 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 comma. And in filter, Alt-Enter, Control-V, and I'm going to ask the question of that looked up column based on whatever the filter column name is in that cell. We want to say, are you equal to whatever the condition is in that cell? Close parentheses, Control-Enter. That's looking pretty wild. If I change this to region, sure enough, that is dynamic. Back to sales rep. Now the next thing we want to do is dynamically select the function. Right now it says average, but we had a placeholder of sum. Now we're going to come over here. Here's the list. And over here we're going to need each function separated by a comma. And I've already put it over there. Copy, Enter, and F2. The thing about this sum is it's not text. It's not a number. It's actually a function object. And the lookup function we're going to use can look up anything, including functions. So we're going to use choose. Now the index number is going to need a number that represents the position of the function in the list. And then we just list value 1, value 2, value 3, all the functions separated by a comma. Now, if that's the function we want, we need a 1, 2, an index number. Well, the perfect way to do that is XMATCH. We'll look up a particular item in a list. And when we close parentheses, now we have a lookup function that'll tell us the position of whatever is in that cell in this list here. Now we come to the end. All these values, I'm going to Control-V. If I click at the end, we can see 14. If I close on choose, I need a comma here so I can access that 3, Control-Enter. And now, look at that. It's already doing average. When I change it to min, that is beautiful. Now, the last thing we need is I need a label right here. And we also need some sort of message. If I select the wrong field here and this hasn't changed yet, then we have a value error. Control-ZZ. Now notice that this is a particular size. If we change this, it's going to be a different dimension. And so what I want to do is use sequence to determine the dimensions of whatever table we have here. So F2, we're actually going to use this as a variable because we're going to use it a few times. So this is where we use let, Alt-Enter. I'll call this P for pivot. Come to the end. So that's the value. P is the name, comma. I need to know how many rows there are, so we'll use the variable R. Rows, how many are there in P? We also need to know how many columns, so we'll call that C of P, comma. And then we need a sequence. So we'll use sequence. And how many rows? R. How many columns? C. Close parentheses, comma, Alt-Enter. And let's check and see if sequence is working. And sure enough, let says it is. Now what we're going to do is we're going to use this, and we're going to say if all the values are here are equal to 1, then put a label. Otherwise, for the remaining values, just plop the P in there, which is our report, F2. So down here, this is the final calculation. If S is equal to 1, then I want a label. Well, guess what? I'm going to link it up here, average, and then ampersand, in quotes, we're going to say of, ampersand, whatever the calculation column is. That's the value if false, the value if true. Well, it's just going to be P. P, close on if, close on let, Control-Enter. And that is a thing of beauty. We have the calculation. We have the label. If I come up here and change this to max, max of sales for each one of those. Now the last thing is if I change this column here, I want to warn them that you have to have the same filter column and condition working together. So F2, right at the bottom, I'm just going to wrap if error right around the if. That if is going to be the value, backspace, comma, value if error. I'm going to type something like that. That reminds them about both possibilities. Close on if error, close on let. Control Enter. Now if I change the wrong column, there's our message. Control Z. Totally dynamic. I want to change this to sum. Actually, we're going to add some more bold here. All I'm going to do is add bold here and across this way. And that should be our finished report. I'm going to change this to product, sales rep. I want to see only in Southwest. And bam, our completely dynamic formula pivot table. Now, two other quick examples. Finance, sometimes we have calculations with lots of intermediate steps. And we want a single function to just calculate the labels and return and standard deviation. That's easy to do, and we can even put it in Lambda and use it over and over. In statistics, we have all sorts of stats we get when we do XY analysis. Well, there it is. I'm using line S, which is a built-in function, because it doesn't deliver the results in a polite way. So I fix it up, add some labels, and just like that, I have a reusable function. All right, there's lots of homework problems for you to do, so you can check those out. And in this video, we talked all about LAMBDA, LAMBDA Helper Functions, and Eta-LAMBDAs. We saw pivot by, group by, MAKEARRAY. We did talk about recursion. We saw reduce, which is related to scan. We talked about map, by row, by column. And we saw how to create reusable lambdas that allow us to show all the formulas in a model, calculate the rate of change, cost of goods sold. And we started it off with, of course, something very important, all the tricks about defined names, because, of course, if we're going to create a reusable function with lambda, we use defined names. All right, we'll see you next MECS video.